Now that we know probability and orbitals, kind of what it basically is, there are different types, and we have 4 different types. We have the S, P, D, and F. S, P, D, and F. The first type is S orbital, spherical. It's the one that we just talked about. It's the one, 3 dimensions, a sphere, okay? And again, remember, it's not like it's a ball or anything. It's just a region where one electron or electrons would be likely to be found. There could be multiple ones in there, but again, region where an electron is likely to be found. This is the simplest type, okay? The simplest type of an orbital, the S orbital. There's no different arrangement. If I try to take that sphere and spin it, it's still going to be a sphere on the same axis, okay? Any rotation around these axes, whether it's the X, Y, or Z axes, it's going to be the same. So there is only one, and this is going to be important, only one arrangement for the S orbital, okay? The second is called the p orbital. Now it's called the pi or p orbital. It doesn't look like pi, you know, the Greek letter. What the p orbital does is it looks like this. It has 3 different arrangements, okay? So we have the X, the Y, and the Z axes. And what a p orbital looks like is almost a dumbbell. Now again, why does it have this bulb? Well, because the electron could be located there, then there, then it's over here. And again, as you continually take snapshots of it, it's in this kind of bulb on either side of the x-axis. So this would be called our px axis. You could also have the p orbitals on the y-axis or the z. So there are 3 types of p orbitals. Realistically, what happens is they all kind of jump onto each other. So they are a little bit more complex, but basically it looks like this. So all kind of on top of each other, looking like this, where you have the X, the Y, and the Z. But that's the p orbital. So more complex as we go down, but still pretty simple. Just, you can call them figure 8 shaped off the center or dumbbell shaped. But that's basically what a p orbital looks like. Okay. Let me go ahead and just quickly. X, Y, Z. The key being 3. Okay, there's 3 different arrangements for the p. The third is the d orbital. I'm going to show you a picture in just a second. I'm not going to draw them. Basically what the d orbitals look like, folks. Whoops. Let me go back here a little previous. Get rid of that last one. Okay. What a d looks like is it may have some double bulbing, let's say, on one type right here. Okay, so there's like in between the axes. So the p is on the axis, the x, y, and z. The d may have the you'll see how many in just a second, but there's different types, and they might be in between. I'm sure you're all intelligent folks and kind of recognizing a little pattern. If the S has 1, the P has 3, the D has 5 different, I guess, subsets, types of that specific type. Okay? And the last is the F orbital. And again, when you get to the F, you're dealing with the most complex type, and those are kind of a little bit different. Let me go ahead and see if we can see a picture here. I got a website. This is the website here, blogs at moundsparkacademy.org. But you can kind of see here this S orbital, only 1. All right, and that is important, the fact that it has 1. The P has 3, the D has 5, and you can see that they're kind of in between. You got this double one, this one you got a ring. And then notice the F. There are, and I should have mentioned, of course, but we have 7. We have 1, 3, so this is the S, the P, the D, and the F. 1, 3, 5, and 7 in the F. So 1, 3, 5, 7, SPDF, that's, you know, as straightforward as you can kind of come when you talk about different orbitals, okay? So we'll go back to the slide here. Should be able to get back to the slideshow. There we go. Where was I? Did it erase everything? All right, so SPDF. There you are. I'll leave it at that for now.